Welcome to The Explainer. Today, we are diving into a story that shows how a really simple, almost childlike observation can completely flip centuries of scientific thinking on its head. And it all kicks off with a question you've probably asked yourself at some point just staring at a world map.
I mean, really, have you? It's one of those things you might spot in geography class and then just forget about. But what if that little feeling that, hey, wait a minute, those kind of fit together, wasn't just some random coincidence? What if it was actually the very first clue in one of the biggest detective stories in the history of science?
Okay, let's just zoom in on the most obvious one, right? The coastlines of South America and Africa. The fit is, well, it's uncanny. For hundreds of years, this was just written off as a fluke. But it turns out this so-called fluke was the key that would end up unlocking some of our planet's deepest, most incredible secrets.
So there it was, a world-sized puzzle, hiding right there in plain sight on every map. All it needed was for someone to come along with the courage to actually try and solve it.
And that is exactly where our story really gets going. You know, back in the early 20th century, one scientist looked at that map and just flat out refused to believe it was a coincidence. Nope. He was totally convinced it was evidence of something monumental.
And here's the first little twist in the story. The person who cracked the code? He wasn't even a geologist, the guys who study rocks and Earth. He was Alfred Wegener, a German meteorologist. Yeah, he studied the weather, the atmosphere, not the ground beneath his feet. But maybe it was that outsider's perspective that let him connect dots that the geologist had been staring at for years without seeing the full picture.
And this was his big, radical idea. Not that the coastlines had just eroded in a funny way, or that some old land bridges had sunk into the sea. No. He proposed that the entire continents, huge land masses, had actually drifted across the surface of the planet over millions and millions of years. I mean, can you imagine hearing that for the first time? It was a staggering concept, and back then, most people just thought he was crazy.
So, okay, if the continents had moved, a pretty obvious question follows. Where did they move from? Well, Wegener had an answer for that, too. He believed that they all started out together, in one place, forming a single, gigantic supercontinent. He even gave this ancient world some fittingly epic names. The supercontinent he called Pangaea, which is Greek for all Earth. And this massive landmass was surrounded by a single, world-spanning ocean he called Panthalassa, meaning all water. So this wasn't just a theory anymore, it was a vision of a completely different planet.
And here it is. This is the solution to the puzzle. This is Wegener's map of Pangaea, showing our world as he thought it looked about 200 million years ago. I mean, look at it. Every continent we know, all locked together. And yep, there's South America and Africa, snuggled up right next to each other. The puzzle pieces fit perfectly.
But look, an idea this huge, this revolutionary, it needs a lot more than just a map that looks pretty convincing. And Wegener knew that. So he spent years gathering evidence, collecting clues from all over the world, following a trail that spanned oceans and scientific fields.
And the list of evidence he put together was, well, it was seriously impressive. I mean, beyond that obvious jigsaw fit, he found ancient rock formations in Brazil that were a perfect match for those in West Africa. He found evidence of glaciers in places like India and Australia, which only makes sense if they were once way closer to the South Pole. He even found matching gold deposits. But his most powerful clue, his real smoking gun, came from biology.
Okay, this is where the story gets really good. Wegener found his best piece of evidence in the fossil record. He basically presented his critics with this little reptile, the Mesosaurus, and a problem that they just could not explain away. Now think about that for a second. The exact same species, a small reptile that lived in fresh water, has only ever been found in two places on the entire planet, Southern Africa and Brazil. And today, those two places are separated by the entire Atlantic Ocean. So you have to ask, how did it get there? The simple answer is, it didn't. There's no way this little guy could have swum thousands of kilometers across the Atlantic. The only conclusion that makes any sense is that back then there was no Atlantic Ocean to swim across. South Africa and Brazil must have been connected. The Mesosaurus didn't cross an ocean, it just walked across the land.
So, with a compelling map and a mountain of evidence like that, you'd think Wegener's theory would have been a smash hit, right? Not quite. For decades, his idea of continental drift was basically laughed at by the scientific community. His theory was, quite literally, set adrift. You see, for all of his incredible evidence, Wegener had one fatal flaw in his theory. He couldn't answer one single crucial question.
how? What kind of force could possibly be powerful enough to push entire continents around the globe?
And this is really where his whole theory started to fall apart under scrutiny. He threw out some ideas, like maybe the tides were responsible, but physicists did the math and said, nope, not even close. The force would need to be billions of times stronger. He had ideas about how mountains formed, but geologists said the ocean floor was too weak for that to work. For every amazing clue he presented, they had a counterargument. And without a believable engine to drive the whole process, his critics just picked his theory apart, piece by piece.
So in the end, Wegener was left with this beautifully solved puzzle that almost nobody believed. He had figured out the what, the continents moved, and the where, from Pangaea, but he just didn't have the how. It would take another 50 years, and the development of technology he could have never dreamed of, to finally find the engine for his theory, plate tectonics, and prove that he'd been right all along. His story is just this incredible reminder that sometimes just seeing the truth isn't enough. It really makes you wonder, right? What obvious truths are we all staring at today, just waiting for the right person to ask the right question?